Hi guys, today we're moving on to Unit 4, Lesson 24, and we're going to talk about nets and surface area. And when I'm talking about nets, I'm talking about what they're showing here, how you take a three-dimensional shape and you lay it out so that you can see all the different sides. So let's move on and learn a little bit more about this. So it says you know how to find the areas of rectangles and triangles. In this lesson, you will learn how to find the surface area of three-dimensional figures such as prisms, pyramids. So let's take a look. How can you find the sum of the areas of the faces of this box? We're going to use the math we already know to solve. So imagine we cut the box open along its edges and lay it flat. It would look something like the picture you see there on the right. A says, how many faces does the box have? So if we go through, when they're talking about faces, they're talking about all the different flat surfaces along the edge. So we would have 1, 2, 3, 4, 5, 6. So we'd have a total of 6 faces. What shapes are they? Well, none of these have two sides that are the same, so they're not squares, so that we could say that they are all rectangles. And then it says how many different sizes of rectangles are there? Well, if we go back and look, we can see that they have it broken down into colors for us. So each color is representing a different size. So we have these two that are the same, so that's 1. Then we can look and see that these two small ones on the outside are the same, so that's 2. And then we can look and see that we have these smaller rectangles here, or medium ones, that would be 3. So there are 3 different sized rectangles. So B says, how do you find the area of a rectangle? Just like we've been doing for the last couple weeks, it's base times height. So we're going to go through and we're going to find the dimensions of the different faces. So I'm basically going to look at these and base it off of our colors. So if we start at the top, our first one, our front and back, we're going to call the front and back the purple ones. Okay? Our 2 sides are the little small ones, so the left and right sides are the red ones, and then the blue ones are going to be the top and bottom. Okay, so we can kind of color code these as we go. So if I look at our purple shapes, our front and back, I can see that it's 9 and the side is 4. So we put 9 and 4. For my blue, which is the top and bottom, it's still going to have the same length of 9, but the side is 3. And then for our little sides, our left and right side, we can see that it's 3 by 4. So, keeping those in mind, let's look at D. It says, find the area of each rectangle, write the number of square centimeters of area inside each one shown in the diagram above. So, if we go back and we'll just start with where we left off with our sides. So if I want to find the area of my 2 sides, I'm going to have to do 3 times 4, which gives me 12. But I have 2 shapes that are this size, so I need to do that twice. So I can multiply it by 2, which would give me 24 for both sides. So then if I come up to the front and back, which was our purple ones, you can see that we did 9 times 4, which is 36. But once again, I have 2 of those, so I'd multiply this times 2. 36 times 2 equals 72. And then we have our front and back, which are the blue ones here, and those were 9 times 3. So 9 times 3 is 27, but once again, there are 2 of them, so we multiply it by 2, which gives us 54. So What I then do to find the surface area of all of it is I add them up. So 4 plus 2 plus 4 would give us 10. 2 plus 7 plus 5 plus 1 would give us 15. So it's 150 centimeters squared. It's still area, so we still square it. So on E, where it says suppose you need to paint the box, explain how you could find the area you need to cover. You would say find the area of each face. Those are those flat surfaces that we counted up here, and add together. So it says in the problem on the previous page, a rectangular prism is what you see, hold on, sorry about that, is what you see right here. It's what that we took and folded out, okay? Is cut and unfolded into a flat representation called a net, okay? Each face of the prism is shown in the net. You can use a net to find the surface area of some three-dimensional figures. The surface area is the sum of the areas of the faces of the figure. So that's what we did on the previous page. You can draw nets for other three-dimensional figures. The triangular prism below has two parallel triangular faces that are the same size and shape called bases, and three rectangular faces. The rectangular faces can be different size. Okay, so you can see you have your two triangles that are the same size, and then you have your rectangular faces from there. So the next 3D shape we're going to talk about is a pyramid. A pyramid is a three-dimensional figure whose base is a polygon and whose other faces are triangles. So you can have a square rectangular pyramid. So this is a square pyramid because it has a square base. The base of it is a square, and you can see that right here on the net when it's folded out. They also have triangular pyramids, which is the same thing, only it has a triangle for the base, and then the sides would come out like this. Okay, both of them are pyramids, but it's just the base has a different shape. So number 1 says, explain in your own words how to use a net to find the surface area of a three-dimensional figure. Well, just like we mentioned before, you find the area of the polygons in the net and add them up. So find the area of each face, each shape, and add them together. So in this problem it says a packing designer wants to find out how much leather is needed to cover the jewelry box shown below. The box is 12 centimeters long, 3 centimeters wide, and 5 centimeters high. Find the surface area of the box. So in the picture, you can draw and use a net to help find the surface area. So you can see that they broke it down and they folded it out. In the model, you can then use a table to organize the information you need. So you can see here that they have the top and bottom and the measurements across. You can see that they have the front and the back, and then the right side and the left side. And then over here on the right hand side, they found the area of each. So let's go through and answer some questions about this now. Look at the model it. How could you find the total surface area of the rectangular prism? Well, just like we've talked about before, we add the area of each shape or face. what is the surface area of the prism? And then it says to show your work. So if we go back and look, we can see that the front and the back are 12 by 3. And I'm going to put an FB for front and back, and then a TB for top and bottom, which is 5 by 12 or 12 by 5. And then we have the sides, which I'm going to use as S, that are 3 by 5. So we're going to take and multiply these out. 12 by 3 is 36, but I have 2 of them, so I multiply it by 2 to get 72. I have 12 times 5, which is 60, but I have 2 of them, so that's 120. And then I have 3 times 5, which is 15, but I have 2 of them, so I multiply by 2, and that's 30. So I take 72 plus 120 plus 30. So I get 2, I get 12, and 2. So I would find 222 square centimeters for my total. So number 3 says, in a rectangular prism, which pairs of faces have the same areas? Well, we kind of already mentioned that with this. So we can say top and bottom. We can say front and back. And the 2 sides. Number 4, how can you use your answer to problem 3 to find the surface area of a prism? Find the area of the top times 2, the bottom, or the front times 2, and the side times 2. Then add. So basically just what we did. Number 5, use the method from problem 4 to find the surface area to show your work. Well, we're going to do the same thing, so I'm just going to put an arrow right back up here. Okay, because we did 12 times 3 times 2, and we did 12 times 5 times 2, and we did 3 times 5 times 2, which gave us this. Number 6, explain how to find the surface area of a rectangular prism. Once again, find the areas of the faces and add. So now I want you to try it. Look at what we did up above and follow those steps. So pause the video, take a couple moments to work your way through this, and then we can resume the video to check your answers. Okay, one thing I want to point out on number 7 is that it is a cube, meaning all sides are the same. So if I want to find my front right here, it would be 4 times 4, which is 16. Okay? Well, if every single side of this shape is the exact same size, we don't really have to break it down into top and bottom, front and back, and side. We can actually take, since all of them are the same, and just multiply it by how many sides there are. So if we have top and bottom, that's 2 sides. Front and back is 2, and then the 2 sides would be 2. So that is a total of 6 sides. So I can take my 16 and multiply it times 6, and I find that 96 centimeters squared is my surface area. Okay, so with cubes you don't have to break it down into each individual shape, unlike with number 8. With number 8, we have to look at each one of those shapes. So let's start with the front. So my front and back I have right here. So this is 8 by 2. So I'm going to label front and back. I'm going to do 8 times 2, which is 16, but I have 2 sides, so that's a total of 32. And then I'm going to go through and I'm going to do my top and bottom. So here's my top. It's 8 by 10. So 8 times 10 equals 80. And then I'm going to do times 2 because there's 2 of them, which equals 160. And then I'm going to do my sides, which are here, and that's 10 by 2, which is 20, but there's 2 of them, so that's a total of 40. Now I'm going to go through and I'm going to add these up. So I have 32 plus 160 plus 40. So that's 2, 13, and 2. So 232 feet squared. So the next problem we have is a triangular prism. So we're going to do the same thing as we did with the rectangular prism to find the surface area. So in the picture you can see that they took and folded it out so that we can see our surface area. Then once again they created the table. So you can see we have 2 triangular bases or faces. So those are those there. Then we have the 3 rectangular sides, and they've done these here, with this being the area of each one. So let's answer some questions. Number 9 says, how many faces of the prism on the previous page are triangles? Well, there's 2 of them. And remember, how do we find the area of each triangle? 1/2 base times height. So on this one, if we look, the area of this triangle would be 1/2, the base is 12, and the height is 8. So half of 12 is 6, and 6 times 8 would be 48 square centimeters, just for one triangle. So then number 10 says, how many faces of the prism are rectangles? Well, there are 3 rectangles. And it says, are they all the same shape and size? Well, in this case it would be no. One is 12 by 11. The other 2 are 10 by 11. Number 11, what is the surface area of the triangular prism? And then show our work. Well, we know that the triangle was 48, but there are 2 of them, so we multiply it by 2. That gives us 96. We know the one rectangle was 12 times 11, which is 132. And we know that the 2 other rectangles were 10 by 11, which is 110, but there are 2 of them, so we multiply it by 2, which equals 220. So then I take and I add up 96 plus 132 plus 220. And when I do, I get 448 centimeters squared. So number 12 says, explain how to find the surface area of any triangular prism, just like we do with the rectangles. Find the area of the triangles and rectangles, then add. Okay, with rectangular prisms we find the area of all the rectangles, then add. Triangular prisms we find the area of the triangles and rectangles, then add. So now you try it. Break it down, find your triangles, then find your rectangles, and then add them all together. Pause the video. When you're done, then we can come back and you can resume to check your answers. Okay, so let's start with our triangles first. So we're going to start with this. We have 1/2 times the base, which is 6, times the height, which is 5.2. So when we multiply that out, half of 6 is 3, And then 3 times 5.2 equals 15.6. But there's 2 of them, so I multiply that by 2, and it gives me a total of 31.2. Then we have our rectangular sides, which is just base times height. So in this case, it shows us that one side of the rectangle is 36, and then we're going to multiply it times 6. So 36 times 6 is 216. Now, if we pay attention though, each one of these triangular sides are the same. So since there's, rectangular sides. Since they're the same, that means that there are 3 of them, and we multiply by 3. So 216 times 3 is 648. When we add these two numbers together, we get a total of 679.2 inches squared. Number 14, we have this one. So we start with our triangles, and we have 1/2 times the base, which is 8, times the height, which is 15. When I multiply that out, half of 8 is 4, and 4 times 15 is 60. But there's 2 of them, so I multiply it times 2. 60 times 2 is 120. So then I look at my rectangular shapes. This one here is 20 by 17, which gives us a total of 340. The shape, the rectangle on the bottom, is 8 by 20, which is 160. And then the rectangle on the back is 15 by 20, which is 300. So I take and I add all of these up. Throw in the 120 from up here as well. So I get 0, 12, and 9. So I get a total of 920 square feet. The last shape we're going to talk about is the pyramid. So here you can see we have a pyramid. The picture, it shows it all cut apart and laying out. And then you have your table again. On this one we have the 4 side triangles and then the square base. So if we answer questions, it says, how many faces does the pyramid have? Well, there are 5 faces, 4 triangles, and 1 square. Okay, and keep in mind those triangles are the same shape and size. So 16 says, how do you find the area of the base of the pyramid? Well, we do base times height, which in this case is 6 times 6, which equals 36. How do you find the total area of the triangular faces? Well, like I said, they're all the same shape and size. So I'm going to do 1/2 times the base, which is 6, times the height, which is 5. Half of 6 is 3, and 3 times 5 is 15. But I have 4 of them, so I multiply that times 4. 15 times 4 would give me 60 inches squared. And this is also inches squared. So, what is the surface area of the pyramid? We would add our 36 for our square plus our 60 for all the triangles, which gives us a total of 96 square inches. And all we did was add the triangles and squares. Explain how to find the surface area of a rectangular pyramid. Just like we said above, find the area of the square and triangle and add. So, once again, use what we did up above, take a moment, pause the video, work through these problems, and then you can resume the video to check your answers. So on number 20, it says Rebecca decides to make her pyramid model much larger. So the length of each edge of the base is 60, and the height of each triangular face is 50. So if we have a base of 50, and then remember this is a square. Sorry, not super great at drawing triangular pyramids here. Alright, so if this is 50 and it says the height of the triangle is, this is 60, the height is 50. What is the surface area of the larger pyramid? Well, we would take 1/2 times 50 times 60. And when we multiply that out, we'd get 1,500. Because half of 60 is 30. 30 times 50 is 1,500. And then we'd multiply that by 2. Which gives us 3,000. But if I multiply it by 2, that's only 2 of the sides. I actually have to multiply it by 4, or multiply this by 2 again, which would be 6,000. Sorry about that. But then I find the area of the base, which would be 60 times 60, which is 3,600. So 6,000 plus 3,600 would be 9,600 square inches. For 21, our base is 18 times 7, which is 126. And then you have your triangles here, which would be your front and back triangle, which is 1/2 times 18 times 10. Half of 18 is 9, and 9 times 10 is 90. But there's 2 of them, so we multiply by 2 to get 180. And then we have our side triangle, which is 1/2 times 7 times 13, which gives us 45.5 times 2, which gives us 91. So then we would add those together, 126 plus 180 plus 91, and we get 7, 19, and 3. So 397 meters squared. So what I need you to do now is to go back to Classroom and complete the exit ticket. Once you've completed the exit ticket, then you can come back into this workbook and work on page 248 through 251.